Good morning to one and all present over here. It gives me a great pleasure in inviting you all for this webinar organized and conducted by AIT and Math Club. We will start this program with the welcome speech by Ms. Anita Rani, HOD of SNH Department AIT.
A very good morning to one and all present here. On behalf of Arifa Institute of Technology, Honorable Chairman, respected Director, respected Principal, and our Arifa team, I am happy to welcome you all on this webinar, Applications of Mathematics in Engineering. Today, I am privileged to welcome our Honorable Chief Guest, Dr. Jamna Devi Ma'am, who is the Professor, Department of Mathematics, AIM College for Women, Nagapattinam. She has 15 years teaching experience. She has presented more than 14 papers in reputed journals. She research interested with operation research, mathematical modeling, decision making models. Finally, I welcome our participants, HODs, and faculty members from various institutions. Once again, I welcome you all for this great occasion. I hand over to the session, Dr. Jamna Devi ma'am. Ma'am, thank you.
Thank you, Anita Rani, for a generous introduction about me. Respected Principal of Arifa Institute of Technology, Isanur. Respected HOD, Anita Rani. Good morning to all. Good morning to the staff members and students present over here on this Sunday. I appreciate your interest shown on this webinar. First of all, I would like to thank the management of AIM College and our principal for permitting to give a presentation to Arifa Institute of Technology, Isanur. Next, thank you for the principal, Dr. S. Malik Raj, for giving me an opportunity to give a presentation in your college. Thank you to the HOD, Mrs. J. Anita Rani, for taking good efforts for the improvement of students' community by arranging a lot of webinars and all. I should appreciate you, Anita Rani. Okay, let me start the session now.
Okay, ma'am. Thank you, ma'am.
Okay, anybody sharing the screen? Anita Rani?
Yes, ma'am.
Yes.
Just a minute, ma'am. Ma'am, you will start, ma'am.
Okay, I'm not seeing the screen. For AIT SNH is there, in which you have shared the screen. Just a minute, I'll find it.
Ma'am?
Yes. Just a minute.
Yeah, ma'am.
Who is presenting the screen? I couldn't view it.
AIT H&S, ma'am.
SNH. There is 4
Yeah.
SNH.
Yeah, ma'am.
Okay. Okay, let me start with a known saying. Mathematics is the queen of science. Many students have a common hatred on the subject mathematics, whereas few have an affinity to this mathematics subject. As I had many teachers and staff members are joined in this webinar, I can make a request to you all. Please connect mathematics they learn to everyday life. As a teacher, you can talk to your students how maths is used in real life, share with them the examples of everyday maths applications so that they will be more likely to view maths as important and valuable. They may also become more interested in mathematics. Remember that as a teacher, you can influence them to how to think about mathematics. So with this request, I start this session. Let me start with few points of how mathematics is used in daily life. Students or everyone can learn skills in algebra classes that will help them with money. One important skill they learn is how to calculate interest and compound interest. So this is a basic thing for a student or any person to go to a bank to calculate simple interest and compound interest. It is used to manage money now and when you grow up. This skill will help them pick the best bank account. It will also help them to decide which credit card is best to have. People who take out loans need to understand interest, how to calculate interest, and what is the sum assured amount. It will also help them figure out best ways to save and invest money. Mathematics is used in sports also. Geometry and trigonometry help the students who want to improve their skill in sports. It can help them to find the best way to hit a ball, find the best angle to hit a cricket ball, etc. It is used in construction of buildings. It is used especially for civil engineers and architecture. I hope first year students have joined in this webinar. Is it? Hello? Am I audible?
Yes,
Yeah,
ma'am.
ma'am.
Yeah. First year students have joined in this webinar, isn't it? All engineers, computer science, civil engineers, all students. Okay. It is used especially for civil engineers and architectures for calculating area. So calculating area is an important scale for civil engineers. It is used for civil engineers to remodel future homes and apartments. It will help the engineers to find how much paint they need to buy while painting a room or a hall or whole building. It is also an important skill for everyone to install new tiles in a bathroom or kitchen or for a home. So first of all, they need to calculate how much quantity of tiles they have to buy, how much quantity of paint they have to buy. So these are the basic mathematical knowledge needed for a civil engineer or architecture. Knowing how to calculate perimeter for calculating the fencing, knowing how to calculate the perimeters, which will help them to make calculation for fencing or building the compound walls, etc. Next, it is also used for even for cooking. People use maths knowledge even for cooking. For example, in our home, we use proportions and ratios to make correct calculation for each ingredient. Suppose we are preparing rice. So 1:3. 1:3 is the ratio of water we have to add to the rice for getting a cooked rice. If the ratio is wrong, the whole family will be starving. So the mathematics is used even for cooking. Just a minute, Anita. Yes. Next, we shall continue with the application of mathematics in engineering. It is used in predicting the weather and to see the MRI and tomography. It is used in internet phones. Let me see one by one in the next slides. Let me give the gist of what we are going to study in this slide. Epidemic analysis, maps of the earth, reading CDs and DVDs, glacier melting, that is global warming, public key cryptography, and lot more. Next slide. Next slide. Yes. In predicting the weather, that is, we all know that atmosphere is filled with lots of gases like oxygen, nitrogen, carbon dioxide, isn't it? All gases are fluid. Do you accept that? All gases are fluid. So in this, fluid dynamics is the main concept used in forecasting the weather. It is used in measuring the movement, density of gases in forecasting the weather. Fluid dynamics is a study of what to calculate the density, the force. So here also in the atmosphere, the gases are filled with oxygen, nitrogen, and carbon dioxide, and many more gases. So fluid dynamics is a main mathematical concept used to forecast the weather. Here, Navier-Stokes equation concept from fluid dynamics is used to solve this problem. In case if we cannot find a direct solution, then we take up the help of supercomputers. Because in mathematics, we can arrive to a certain equations which cannot be solvable, so that we can seek the help of computer engineers. Any computer engineers here? Yes, I think so. Why no one is answering? Okay, so mathematicians need computer engineers to predict or forecast weather. The entire atmosphere is divided into millions of blocks. Say, for example, 1 cubic kilometer. 1 cubic kilometer of atmosphere is divided into millions of blocks. Use numeric simulation from numerical analysis to forecast the weather accurately. Yes? Yes, someone talked in between. Okay. The entire atmosphere is divided into millions of blocks. Say, for example, 1 cubic kilometer. Here, the concept of numerical analysis is also used to forecast weather. So, in predicting weather, we take the help of mathematics. We can see two concepts. One is fluid dynamics, that is used to calculate the flow or the movement, the density of gases to forecast weather. The another thing is the use of numerical analysis to form numerical simulations. So in this, for predicting weather, geology students and computer science students are very important, and they get job opportunities with the help of mathematics. Next slide. So MRI and tomography. So what is MRI? We have heard a lot about MRI. Suppose a person hit by an accident, they will say that he has undergone MRI scan. So MRI is nothing but magnetic resonance imaging. Magnetic resonance imaging. In MRI scanning, the concept of mathematics and physics altogether is involved. So magnetic resonance imaging, MRI, is a type of scan that uses strong magnetic fields and radio waves to produce detailed images of the inside of the body. So we can see what is happening inside the head, what is happening inside the heart while taking an MRI. It is a large tube that contains powerful magnet. You lie inside the tube during the scan. In pictures, you can see a man is put lie down inside a tube, inside a large tube. The large tube is full of powerful magnet. The person will lie inside the tube during the scan, isn't it? That the concept of three-dimensional analytical geometry is used to predict what is inside the brain or body. So you can see in this figure, while taking MRI, the head is of three-dimensional, isn't it? The head is three-dimensional, but the scan report is two-dimensional. So we should collaborate both the three-dimensional and two-dimensional. One should need the knowledge of both the three-dimension and two-dimensional knowledge. So what happens while taking MRI? Countless two-dimensional snapshots are taken. So we know what is a snapshot, screenshot, isn't it? So countless two-dimensional snapshots are taken while taking MRI from different directions. And from this, a three-dimensional model is formed using the two-dimensional snapshots. This process is called tomography. You understand what is tomography? Tomography means, first of all, the head or brain is taken countless two-dimensional snapshots from different directions, and it is again converted to two-dimensional snapshot, so that only we can have a scanned report, and the doctor can predict what has happened inside the head, whether the brain is opened, whether the skull is opened, whether the neurons are okay. Okay, now we can realize how mathematics is used in saving lives of peoples. So in taking MRI and tomography, the role of mathematics is vast, is appreciable. So we can realize how mathematics is used in saving millions of lives. Next. Internet and phones. So this portion everyone likes.